Hey guys.
Hey Bo.
Hi Bo.
Flippin' physics.
Ladies and gentlepeople, the bell has rung, therefore class has begun. Therefore you should be seated in your seat, ready and excited to learn about displacement and distance.
Yes.
Alright, let's start with displacement. You should already know quite a bunch of stuff about displacement from your reading last night. So Bo, why don't you tell me something about displacement?
Displacement. Isn't it like the distance between where you start and end?
Yeah, but you also need to add that it's not just the distance, but more specifically the straight line distance.
Exactly. One thing that you should know about displacement is that it is the straight line distance between the initial and the final points. Bobby, why don't you tell me something more about displacement?
Displacement has direction.
Yes, this is a very important piece to remember. Displacement absolutely has direction, and whenever you are writing down the displacement, you need to identify the direction. Billy, tell me something more about displacement.
I can't think of anything else.
How about the symbol for displacement, Billy?
Oh yeah, the symbol for displacement is triangle X. The name for the triangle is delta.
Yeah. It's the Greek symbol uppercase delta.
True, the symbol for displacement is delta x. Who can tell me what delta stands for here?
I'm pretty sure that delta means the change in something.
Yes, Billy, delta does mean change in. Bo, what does the x mean?
X means distance.
Actually, no, Bo, x does not mean distance. People often confuse x with distance, but x actually stands for position. X stands for position. So again, x means position. And if delta means change in and x means position, then delta x or displacement actually means the change in position of an object. So the symbol for displacement is delta x, and that literally means the change in position of an object. So let's return back to the fact that displacement is the straight line distance between the initial and the final points. Bobby, this brings us to an equation. What equation does delta mean?
I'm not sure.
Oh, I remember. Delta always means final minus initial.
Oh yeah, so delta x means x final minus x initial.
Actually, we should probably say displacement equals position final minus position initial, right, Mr. P?
Yes, let's get in the habit of actually saying what the letters mean rather than just the letters themselves. I find that we all understand much better what's going on when we actually say what the letters mean and not just saying the letters. It's a good habit to get into. Great, we now have the equation for displacement, or delta x. So the displacement is equal to position final minus position initial. But what else do we know about displacement?
I'm pretty sure it can be negative, right?
That's true. Displacement can either be positive or negative. Could you all please give me an example for a dimension for displacement?
How about meters?
Feet?
Kilometers.
Sure, any linear dimension will work. Some other examples for possible dimensions are furlongs, rods, angstroms. The furlong, of course, being the distance that a team of oxen can plow without needing to take a rest, or the length of one furrow. A rod being 5.5 yards, and an angstrom 1/10 billionth of a meter. The most common dimension for displacement would be the base SI dimension for length, which is, of course, class
Meters.
meters, feet, furlongs, rods. This right here this number is called the magnitude of the displacement. And the magnitude of the displacement is a very important term. The magnitude simply means the amount of, the number of the displacement without the direction, the value without direction. It is very important that you remember that displacement has both magnitude and direction. So class, what two things does displacement have?
Magnitude and direction.
Then class, are displacement and distance the same thing?
Yes.
Let's try that again, class. Are displacement and distance the same thing?
No.
Yes. Okay. Well, does distance have direction?
No. I don't think so.
No, distance does not have direction. Again, distance does not have direction, so are displacement and distance the same thing?
No. Displacement and distance are not the same thing.
Good. Displacement does not equal distance. They are not the same thing. We'll go through some examples in just a moment that illustrate that fact. But before we do so, let's talk about and illustrate some directions. We generally have three different ways of describing direction. One of them is the Cartesian coordinate plane with positive y, positive x, and negative x. We can also talk about relative directions with up, down, left, and right. Please notice that by default, up is positive, down is negative, right is positive, and left is negative. Notice how this follows the Cartesian coordinate system. So again, up is positive, down is negative, right is positive, and left is negative. These are the defaults for these. We can of course change them, but by default, that is true. Sometimes we're also going to use cardinal directions, for example, north, south, east, and west. It's very important that we know these, so we're actually going to take a moment to review them. So we are going to take a moment to review the cardinal directions because I want to make sure everybody's on the same page and knows their cardinal directions. So please understand that you are actually all facing north at the moment, which will help you out. So everyone please point east. Good. Please point west. And now point north. So, unfortunately, this is a common mistake that students make, which is the main reason we're actually going through this. The fact that up and north are not the same thing. So please remember up, north, not the same thing. So, one more time, please point north. And now point up. North. South. Great, we got our cardinal directions down. Next, let's go through some examples. So let's say that I start right here. And I end right here. Bo, what was my displacement?
2 meters. You forgot about the direction.
Oh yeah, 2 meters east.
Yes, 2 meters east. That direction is so important. We could also describe it as 2 meters in the positive x direction, 2 meters to the right, or of course 2 meters east as you said. Bobby, what was my distance traveled?
2 meters.
Yes, my distance traveled was 2 meters and my displacement was 2 meters east. That means in this particular case that the magnitude of the displacement and the distance traveled were the same.
Yeah, because you walked in a straight line.
Let's do another example. Let's say that I start here. And I end here. Billy, what is my displacement this time?
Let's see. I need the straight line distance from your initial point to your final point. However, those 2 points are in the exact same location, so your displacement is 0 meters.
We don't need dimensions on 0.
We would if it were temperature.
But this isn't temperature.
True, I was just saying.
Yes, because I started and ended at the same point. The straight line distance between my initial and final points is equal to 0, and 0 does not have any dimensions. What then would be the direction on my displacement? Bo?
You can't have a direction on 0.
Correct. So my displacement was 0, and we do not have a direction, we do not have dimensions on that. Let's do one more example. Again, let's say that I start here.
This guy is strange.
Yeah.
Billy, what was my displacement?
The displacement is actually exactly the same as the first example. So your initial and final points were the same as the first example. So it doesn't matter what you did between those 2 points, the displacement will be the same as the first example. So 2 meters east, 2 meters in the positive x direction, or 2 meters to our right.
Exactly right. None of the middle stuff matters, only initial and final points.
Can the distance ever be less than the displacement?
That's a great question, Bo. However, I do need to add one word to your question, and that word is magnitude. Will the distance traveled ever be less than the magnitude of the displacement? Bobby, what do you think?
Well, the shortest distance between 2 points is a straight line, and that by definition is the displacement.
The magnitude of the displacement?
The magnitude of the displacement. So the distance traveled can never be smaller than the magnitude of the displacement. In fact, that means that the distance traveled will always be greater than or equal to the magnitude of the displacement, right?
Absolutely, because the shortest distance between any 2 points is a straight line, and displacement is defined as the straight line distance between the initial and final points. The distance traveled will always be greater than or equal to the magnitude of the displacement. That is my introduction to displacement and the differences between displacement and distance. I hope that you enjoyed learning with me today. I enjoyed learning with you. I think I might go take a nap.
Lecture notes are available at flippingphysics.com. Please enjoy lecture notes responsibly.